Hi, everyone. My name is Gaby Uribe, and I'm joined by Sarah Chen and Tabby Bandy-Vizcaino. We've conducted a literature review and will be presenting on the mechanics of structural neuroplasticity and the impacts of various types of training-induced learning. Neuroplasticity is the brain's ability to change and adapt due to various experiences. We will be focusing on structural neuroplasticity specifically, which is the brain changing its physical structure as a result of learning. Two major mechanisms of neuroplasticity are neurogenesis and synaptic pruning. Neurogenesis is the formation of new neurons from neural stem cells. This process consists of stem cells proliferating or splitting until they become indivisible. Then they migrate to their final destination and differentiate into a specialized type of neural cell or glial cell. Finally, synapses are formed between neurons. Synaptic pruning occurs largely throughout childhood and early adulthood and is the targeted elimination of synapses that are infrequently used, leading to a more optimized neural network.
One interesting mechanism of neurons is coincidence detection. The postsynaptic cell has AMPAR and NMDAR receptors. NMDAR is initially blocked by extracellular magnesium and generally contributes very little to synaptic activity. When there's simultaneous activation, the cell becomes depolarized, releases the magnesium, and opens the channel for calcium and sodium flow. This increase in calcium is critical for long-term memory development and spatial learning.
Probabilistic neuroplasticity is a probability that an influence could cause a variation in neuroconnections formed by the brain. We have the following neuron state equation, which is the superposition of the following ODEs, and X is equal to the activation level. Degree of neuroplasticity is looking at the mode of all of the activation levels. And so finally, we have our probabilistic neuroplasticity model, and it has great applications in machine learning, behavioral science, and psychology.
Short-term plasticity works to adapt quickly to sensory information on the scale of milliseconds to minutes. The calcium concentration is used to immediately change the probability of activation, and over time, it keeps track of the firing rate history. Long-term plasticity happens in response to this history and over the course of hours or days, like something you would see in brain training.
There's been numerous research done on training-induced learnings and its effects on neuroplasticity, specifically looking at physical exercise, arithmetic, and learning new languages. Thank you so much for listening to our presentation.